Hello, kia ora, good evening. Hope you guys are doing well. Welcome to one more session of Coding Nights. And tonight we have a guest speaker. So we have Shahid Iqbal. So he is a member of the Azure user group in Auckland. Hello, Shahid. How are you?
I'm good, thank you. Yeah, how you doing?
Doing well, thank you. Yeah, it's just a pleasure having you here and being able to share a little bit of your experience with us. That's a session for developers, and I would say it's always interesting to see different people's perspectives, right? And from experienced developers. Yeah, I'm just really happy to have you here, and it's an interesting topic, right? So what are you gonna be talking about tonight,
Yes.
right?
So I think as developers working with the cloud, it's very difficult to be completely detached from dealing with the actual cloud resources. And to date, the tools that most people use to provision their cloud resources are, dare I say, primitive. And I think there's a flow that developers use for their code that is very applicable to infrastructure. So I'll be talking about this tool called Pulumi and how not necessarily just a developer, but anybody can actually use this tool that fits a lot better with the developer's mindset and workflow as well. So that's kind of why I mentioned the developer centric approach.
Cool.
I'll talk a little bit more once we get going on the specifics of that as well.
Cool. Let me just talk little bit about yourself. And so it's just like a bio. You're gonna hear about something you're very familiar, but just to give some sort of introduction to the audience. So Shahid Iqbal, he works at Aura. And he's a Microsoft MVP, and he's the principal platform architect at Aura in Auckland, here in New Zealand, and he's a hands-on on cloud architect implementing modern platforms, predominantly in Azure, focusing on PaaS in cloud-native approaches to solving modern business and software problems. With an extensive background in software development, DevOps, and cloud architecture, he brings the principles to help teams to deploy and run their software in most efficient and scalable way the modern cloud platforms offer. Shahid is also a frequent speaker at both international conferences and local meetups, runs workshops on cloud native technologies, and he is a co-organizer of the Auckland Azure Meetup. When he's not working, he's likely to be talking about cars, photograph, or gadgets. It just feels like a boilerplate, but in general, I think it just brings some awareness to the user group. And but yeah, it's a high caliber guest speaker tonight. And what I would before Shahid, you take the floor. I'd like just to introduce the user group for if you're joining for the first time or not. But I always reinforce that is that we're a community of developers that we love coding, following best practices. Right? And the main intent of the user group is to enable developers with practical knowledge, right? And getting to do hands-on because you learn and you can launch your career, right? From as a junior developer to a lead developer, architect, you have always something to learn with the user group. The other thing I bring is that we are part of Azure Tar, which is a community focused on cloud native solutions on Azure. And also we're part of .NET Foundation because we focus on .NET development. I think with that mentioned and no further ado, I would like just to give the floor to you, Shahid, and for you to continue.
Thank you so much. So yeah, welcome everybody. I this time zone, so 8 p.m. in New Zealand, 5 a.m. I guess for in Brazil,
Yeah,
and also
I didn't mention that, but I'm overseas at the moment. Yeah,
I appreciate you waking up at 5 a.m. and to help run this. So that's awesome. And then, of course, we're in a reasonably friendly time zone for the UK and Europe, where I'm originally from as well. Although it's Monday morning, so I suspect people are still getting their coffees in. So yeah, if we switch over to I guess my slides, we can get started. So so welcome everybody. Quickly want to touch on my bio that Marcel mentioned, but really he mentioned that I have a background in software development. So my career is fairly unusual in that I went from a science background, but this talk is focusing on cloud infrastructure. But I hopefully you'll see why I, somebody with a fairly long software development background, really fell in love with this tool. So although I don't do software development in the traditional sense anymore, I don't do feature development, I'd like to still think I am in that space. The other thing just to mention quickly is, I'm reasonably active on Twitter, so you can catch me on Twitter, or you can find me on LinkedIn. If you've got any questions, please stick them in the chat. I will try and get to them as we go along, ideally. But obviously, if I miss something or you have questions afterwards, feel free to reach out to me on those points as well. So what I want to talk about today is the options people have at the moment for provisioning cloud infrastructure, and then I'll talk about some of the limitations. And again, I think there's a bias here with software developers in mind, so hopefully that will resonate with you if you're a software developer. And then we'll talk about this tool called Pulumi, which I've started using a lot and I'm a big fan of. So when we think about provisioning cloud infrastructure, the first place most people end up is the portals, the cloud portals. These are, each of the cloud providers have their own portals, and to be honest, it's not just the cloud providers, lots of other providers, but we will focus predominantly on the three main cloud providers in the early part of this talk. Why are these portals really popular? Well, one of the key bits is discoverability. So folks who don't know what they don't know, until you go in the portal, you can see what resources you have available to you. You might not know that until you see that in the portal. When you are trying to provision a resource, there's often wizards that guide you through the steps, and they give you options that you can pick from a list. And all of these things are really key in order to provision a resource, because there are essentially parameters you need to pass to the cloud provider, and the portal really helps you with that. Another key area with the portals are they generally will validate your input. So if you're trying to create something with an invalid name or something else, they will generally give you an error and stop you there. And all of these really make your experience, your first time experience working with cloud infrastructure, generally not too difficult to get started. Of course, there's some drawbacks with this approach. Key one really is you can't do it repeatedly. It's very hard to be consistent. I'm terrible at this. I will name something one way, and then if I do it again manually, I will name it slightly differently. It's just a terrible habit I have. So it's very hard to be consistent when you're doing these things manually. Some of the options you want can be buried in a submenu. So when you're new to the resource, it's great because you need to be guided. But when you know what you're doing, the fact that you have to click 4 times to set a value can be really annoying and quite cumbersome. And another really obvious one is when you're trying to create lots of resources, then it's very slow. It's really just you and a mouse. That's as fast as you can go. You can't run things in parallel or to a limited extent. And then one other challenge that you may not necessarily think about is when you're provisioning a bunch of cloud resources, you would generally need to resolve those dependencies yourself. So say you're creating a SQL server and then you need a connection string for a web app. You need to resolve the order that you do those in. And okay, we're humans, we've got brains. It's probably not too difficult, but it's something you do need to do. So with that in mind, then there are other ways of doing this, and a concept or term that's probably quite familiar now is something called infrastructure as code. I'm not going to read the whole definition here, but essentially what it's saying is we have machine readable files that we can specify what we want, and then the machine can read them. We'll come back to this term a little bit later because I have some issues with it. But so how does this look when we talk about the cloud providers? Well, natively, most of the cloud providers have something that allows you to do this. So in Azure, we have Azure Resource Manager. In AWS, we have CloudFormation, and then Google has Deployment Manager. Now, there's variations on top of this. So as we'll go through, we'll dive a little bit deeper. We'll use Azure as an example. I use Azure every day. We'll use ARM templates. Now, some of you may be familiar with Bicep, which is the slightly newer way of provisioning resources. We'll touch on Bicep towards the end, and I'll kind of compare it to everything we've seen. But initially, we'll focus on ARM because ultimately, at the moment, Bicep translates to ARM anyway. So ARM is the native language, if you like, of the resource of the Azure Resource Manager. So here's an ARM template, an Azure Resource Manager template for provisioning essentially just a storage account. Now that's a lot of text and it's quite small. So let's just break it down a little bit. First glance is it looks like JSON, right? This looks like JSON. I've got quotes, I've got curly braces. It looks like JSON, so that's all good. So up here, what we're doing is we're defining some parameters, and we're setting a default value. So this is quite good in a way because what we're doing here is we're allowing the person who's using this template to specify a valid value. They pick from a list, and if they don't pick one, they get an error. So that's great. We're getting some of that validation that we got in the portal. One downside of this is if Azure releases a new type of storage account or new SKU of storage account, we would need to go and find all of our templates where we've defined this list and update them. So that's not great, but perhaps doesn't happen that often. So that's all good. So there's our parameter. And then the next thing we're doing, defining here is a location, and its default value is something that doesn't look like it fits in JSON. This is the first hint that something's starting to go wrong. It looked like JSON before. Now we're getting these curly braces, these square brackets that would normally be used for arrays, but not inside the quotes. Something looks a bit weird here. This doesn't look right to me as a developer who works with JSON. This doesn't look right. And it's a kind of a clue as to problems to come. So once we've got that, we can go ahead and create a storage account. Now, the specifics here doesn't matter too much. I guess all I'm really trying to drive home is, one, how verbose it is, but also there's more and more of these weird syntax starting to appear. So now we're referencing, we've got a variable. So this is referencing a variable storage account. And we're looking at parameters called location and another parameter. So now we're seeing to see more and more of these parentheses here that aren't normal, not something I would expect in a normal JSON. But once I've got that template, the nice thing is that template's essentially self-describing. So what I can do now is ask the Azure CLI as one tool to create me a deployment. So I need to have a resource group. So those who may be not super familiar with Azure, resource group is essentially an organizational structure within Azure that lets you contain all the resources that you want to keep together. There's nuance there, but we won't go too far off topic. And what I can do is I can create this deployment by giving it that file that I've just defined, that template file. And the nice thing with this is now consistent because that file, as long as that file isn't being changed randomly, that file is the same. I will run it. I should get the same result, and that's great. We're getting some consistency. If I want to run this file multiple times, I can do that, and it should be the same, broadly the same result. So we're getting some consistency there. But you saw the fact that there was a lot of stuff there for creating one storage account. So in terms of the pros, which I'll just quickly recover, I guess this can be automated. These templates, we can automate them. They're great. They are declarative, so that's quite important distinction, and we'll touch on that later on as well. So the file describes the end state that you want. It doesn't necessarily tell ARM how to go about creating all the resources. It just says, this is what I want, and ARM goes away and figures out how to achieve that, and that's great. As I said, those things can be easy to kind of do multiple resources. We just add more things in the file, or we run it multiple times. And broadly speaking, with the ARM template, you saw where we were referencing other values because to some degree that approach, the ARM template can, broadly speaking, resolve its dependencies. So it knows that I need to create this resource first because I need the value from that resource in the next resource. So that can be quite helpful. Now Now, in terms of the issues, the drawbacks, I think the main one is that really, one of the main ones is that how verbose it was. There was that whole page of quite small text in order just to create a storage account. And then the big one that really kind of, I guess, started really winding me up was this special syntax, this syntax that was specific to how we do things in Azure, and that syntax is specific to each cloud provider. So I'm using Azure as an example, but I'm sure there's the same examples in the other cloud providers as well. And then finally, in terms of the kind of Azure Resource Manager and the code that runs that and manages it, that's all closed source. We have no idea how that stuff works. So with that in mind, for a number of years now, there's been other tools created to try and help deal with some aspects of what I talked about, and Terraform is probably one of the most popular. So this is a tool from HashiCorp, and they use their own markup language, which we'll look at in a second. But it is a lot terser. It's far less verbose. So that's a good start. The other key advantages of Terraform is it's multi-cloud, multi-platform. So using Terraform, you can provision resources not only on Azure, you could also do that on Azure, AWS, Google, and tons of other platforms as well. So using the same tool, you can now target multiple clouds rather than just ARM can only target Azure, CloudFormation can only do AWS. Terraform is an open source tool and it's written in Go. Go is the kind of cloud native language of choice for most cloud native tools. Maybe Rust will take over at some point. Rust seems to be the current hotness. So let's have a look at creating a storage account in Terraform. And in fact, we're creating two resources here. So this didn't fit on the other slide. So we're doing more work in this slide here. But we've created a resource group at the top there. And then what we're doing here is we're creating the storage account and we're referencing the resource group name. We need to tell the storage account which resource group it's in. And now we're seeing a syntax, which again is maybe not brilliant, but as a developer, it's slightly more intuitive to me. We're now dotting into something. We're doing a dot and a dot. That's syntax that I'm a lot more familiar with. Now, as I said, the rest of it doesn't look super common. It's not quite JSON. It's not quite YAML, thankfully. It's a weird hybrid, but maybe I could get used to this. So as I said, I guess the issues with Terraform is that it's Terraform only. You learn the language, you learn the HCL, and you're broadly speaking targeting Terraform. I don't know. I know some third parties are probably adopting HCL as their own kind of config language of choice as well. So maybe that statement's slightly dated now. But broadly speaking, I think that's reasonably accurate. One of the big issues you run into with tools like Terraform is they have this provider model. So for each of the cloud providers, they will have a specific provider that targets that cloud provider. Now, whenever a cloud provider creates a new resource, there's often inevitably some level of delay between that feature being available in the cloud provider and then it being available in Terraform. Now, it does depend a fair bit on how closely those two parties are working, whether the provider is something the HashiCorp is working on versus a community effort. But sometimes you can run into an issue where there's a feature, or usually, to be honest, more often a setting or something that Terraform doesn't support and may not support for weeks, months, maybe even ever. But so there's this lag, if you like. And then the other, it's probably unfair to say it's a con, but state management. So Terraform maintains its own state of your deployed resources. And if you're using Terraform, you need to kind of manage that state, and you need to be a bit careful, because unless you're careful, some secrets can kind of leak into that state as well. So, yeah. This all works fine when we are doing really simple things. Like the examples I showed you was a single storage account, and ARM was already starting to have some weirdness. Terraform looked okay. But what if I want to do conditional logic? So in our example, we have a QA environment, we have a sandbox environment, we have production environments. We deploy subtly different resources. Now, by subtly different, let me give you a concrete example, geo-replication of our database. So in QA, our QA database is all dummy data. We don't really get any benefits from geo-replicating that and paying, for a geo-replica. So we don't have a geo-replica in our QA environment. But for production, we absolutely want a geo-replica. So when we start needing to do these conditional deployments, then these templates start getting a little bit tricky. Loops is another big one. So if I'm trying to provision 4 or 5 storage accounts because I need them for slightly different things, it's very difficult to do that. And then you hit another issue with third-party code. So if you're trying to interact with a third-party service who doesn't necessarily have a provider, so in ARM you can't, you have to drop down and do PowerShell or whatever. If you're in Terraform, you might have a provider available, which is great, but you may not. At which point you will also have to probably drop down into some kind of script or third-party scripting language of some kind to achieve what you want to achieve. Excuse me. So let's have a quick look at some of these examples of the problems. So this is now an ARM template, and we're looking at conditional logic here. So I'm going to whiz through this a little bit, but hopefully you'll get the point. So up here, what we have is now we have a parameter which says, basically, is it production or not? And the allowed values are yes and no. Now, if I want to deploy a resource only if it's in production, what I now need to do is add this condition attribute. And then I'm using even more weird syntax. And now I've got this, what looks like an equals function that I'm passing in a parameter. And then I'm saying, does that equal to yes? We're developers, right? Yeah, we can roughly work out what that means. That's all good. But if you don't work with ARM day in, day out, you're probably gonna have to go and double check exactly what that syntax was like if you come back to it 3-4 months later. And it does get worse as well. So, let's have a look at an example of this on Terraform. Terraform is, again, well, it's weird and also slightly more developer friendly, if you like. So in Terraform, what we're doing is we're specifying the count, so the number of instances of this resource, and we're referencing a variable is prod, but we're using a ternary expression. So I guess my bias as a developer showing there, like I find that really readable because it's a ternary expression. But yeah, maybe if you're not from a development background, maybe you wouldn't like that either. Let's have a look at loops, and to be honest, loops is where things really start falling down for me. So here's an ARM template where we are trying to create 2 web apps, one in production, one in development. So really the bit we want to zoom in on is I want the name of the web app to basically be my app dash production or development, depending on which one it is. So now what we're doing, excuse me, is we're using this copy section here to copy this resource, and the count of that, we're using the length of this array. So in any world, you'd say that's a bit of a hack. And then really where stuff gets complicated is what on earth is this doing? So this is now looking at the parameters, and it's this copy index function. Yeah, I work with ARM regularly, and I would have to look this up if I haven't used it regularly. A bit like regex for me, to be honest. Maybe I'm just not very clever. That's always a factor, I guess. Yeah, this is kind of lunacy, and I guess where does it come from? Well, we started off with essentially a markup language, and now we've started to shoehorn these programming constructs in there because we want to do programming things with it. And we'll come back to that theme in a second. Quickly, just for completeness, have a look at Terraform. Terraform does this slightly better. So we're looking at the length of the array. So up here we've got an array. Sorry, I zoomed through that a little bit. So up here we've got an array of environments. And then we're doing the count trick again. So length of the array, but now the name is, we're basically indexing into that. So this syntax is slightly more readable, but again, would you necessarily remember it? And again, these are actually reasonably straightforward examples. Now, imagine you had a more complex situation where you had perhaps 2 or 3 resources that depended on the values from each other, but also was needed to be a collection. in normal code, you would probably create some kind of custom config object and have a collection, a list of those objects. You can't do that very easily in these kinds of markup languages. And then I kind of I mentioned the third-party stuff. So usually with things like Terraform and ARM templates and all the other ones, you normally have to drop down into some kind of script. Challenge with that is it can be quite difficult to test this because the script itself is perhaps dependent on some of the other resources. Another big issue you run into is, well, it needs the tools on the machine that you're running that tool on. So if you're trying to run these things on some kind of server somewhere, then you need to make sure you've got the right PowerShell commandlets, for example, and the right PowerShell version and all of that. And it's yet another language to learn. Now, don't get me wrong, it's always good to learn multiple languages, but because if your job is to manage your resources and you're really primarily focused on building features, this probably more applies to smaller teams. You probably don't want to learn the intricacies of PowerShell just so that you can provision 2 websites and a storage account and a SQL server. That's not your primary purpose at this point. So we come back to this statement, and the word that stuck out to me, and again as a developer, was code. And I think of code and I go, well, yeah, what I saw there was, if you're being generous, you'd call that code, but really it's just some horrible concoction of JSON and special syntax. So some people, I think the Pulumi folks first mentioned this. It's not necessarily a term that stuck particularly, but I like it in the fact that what if we had infrastructure as software instead of infrastructure as code? If code has that meaning, then let's call it infrastructure software, and that's kind of the purpose. And that's where this tool called Pulumi really comes in. So Pulumi is an open source project. There's one element of Pulumi which isn't open source, but everything else is open source. It uses modern general purpose programming languages to provision your resources. So now instead of having to learn this weird syntax, you're using languages that you are probably familiar with day in, day out. And we'll have a look at that. It supports many, many platforms, so it's not specifically targeting, say just Azure, for example. And a big one here, which I think a lot of people mistake or get confused about, despite what it may look like when you look at the code, this is a declarative system. So when you look at the code, you may think it's imperative, but it's not. It's declarative, and we'll try and talk about that when we get to the relevant bits. You can run Pulumi for free if you want. You don't need to pay Pulumi a single cent, but that will mean doing some of the things yourself. That Pulumi does have a service, the Pulumi console, that makes life a lot easier, which we'll talk about in a little bit. So in terms of the languages, I suppose, maybe runtimes are slightly more accurate, but they blur the lines there. So you can use Node.js, so that typically you're going to be using TypeScript to do that. .NET Core, which is .NET is the language that I'm most familiar with. It's the language I spent many, many years as a software developer writing. They also have support for Python, Go, Java is fairly recent, and then this YAML provider is quite an interesting one. So it's funny because one of the main platforms that you can target with Pulumi is Kubernetes, and one of the selling points was, hey, look, use Pulumi to get rid of your YAML, and now you can use YAML to target Kubernetes and then write YAML with YAML. But anyway, it's a fairly interesting idea. Essentially, what they're trying to do with the YAML provider is, if you're doing something very, very simple, like that storage account example, then you can describe that in a very small YAML file instead of having any code whatsoever. I'm not sold on it at the moment, to be honest, but I can see why people asked about it. In terms of providers, so Pulumi has what they call the Pulumi Registry, where they have a bunch of providers. These are either ones that Pulumi have created or ones that other people have submitted as well. Just take a sip of water. This screenshot's from a couple of weeks ago, and there was about 96 packages there. And you can create your own as well and submit them, or you can just use them locally if you like. So one other thing I'll quickly touch on, if you are looking into Pulumi, you'll come across, if you see a provider called Native, you may then also see the similar provider called Classic. So when Pulumi first started, they were using a lot of Terraform's underlying providers, actually, funnily enough. They were leveraging Terraform's providers, and that was great initially, but Pulumi suffered from some of the similar problems that Terraform has, in particular around the time it takes to support new features. So in the last few years now, Pulumi has also been providing these what they call Azure native providers. So these are providers that Pulumi creates, and they are generally code gen directly from the cloud provider's API. And what that means is that any changes in that API are generally reflected very quickly. So sometimes the same day, usually by the next day, you will have that kind of feature in there. So that lag, that problem of things taking a long time to be supported, is significantly reduced with these native providers. I believe they now have an AWS native one as well, and possibly a GCP one. I'm not. I struggle to keep on top of the Azure cloud, so the other clouds are generally quite hard to keep on top of. In essence, any application or any platform that exposes a very a decent API for doing essentially CRUD operations, you could probably put a Pulumi provider on top of. So how do I get started? So Pulumi uses a CLI. That's one of the key tools when you're using Pulumi. So once you've installed the CLI, so it's cross-platform CLI, what you can do is you can ask Pulumi to create you a new project. So here I'm telling it to create a new Azure C# project. There's a bunch of built-in templates. So there'll be Azure C#, TypeScript, Go, Python, AWS equivalents as well. And then it gives you a small wizard, if you like, that essentially generates some code for you. So it's generating a project for me, and you can see it's you're seeing hints of it. This is a .NET project, so we can see some .NET stuff. This some of these embedded things that you're going to see are a little bit old, but we'll dive into a demo a bit later where you'll see something that's hopefully a bit fresher, a bit newer. So what does this? So what does this project look like? So I'll open up that folder, and this is what Pulumi has created for me. And yeah, first glance, you look at it, and it's basically a CS project. It's a thing. Let's dive into that. And what we can see is it's a console app. It's a .NET console app. As I said, this one says it's 3.1. If you do this now, it'll be targeting Net 6. And again, this package reference is a little bit old as well. But the concepts I want to show you in these next few slides doesn't really matter what version I'm showing you here. So let's have a look at the actual code itself. So this is program CS, and what we can see here is we're creating variables. We're creating a variable called resource group, and that's a new Azure resource group. We give it a name, and then where this stuff really starts coming alive is a little bit similar to what we saw in Terraform, but now when I'm creating a storage account and I need that resource group name, I'm using standard .NET. I'm doing a dot into the name. I'm getting IntelliSense. I'm getting all of the validation and stuff I'd expect. So if I type out that name, I would get a compiler. It wouldn't compile because that's not valid. That name is coming from the property of the resource group object up here. So once I have that, so that's just a storage account. So let's quickly just jump back to that second. So that's how many lines of code it is to create a resource group in a storage account in the most basic sense for the actual resources. So once I have this, how do I go and create the storage account? Well, I need to be authenticated to Azure. So there's a number of ways of doing this. So you can authenticate by signing into the Azure CLI on your local machine, and then when you run Pulumi, it will pick up that context. Or you can specify things like a service principal details as well. When you're running this in a more production scenario, you're going to want to use a service principal. But when you're doing local dev, your local account is probably the right choice. So once I have that, I go back to Pulumi CLI and I will do Pulumi up. So those of you who are familiar with Terraform, similar semantics, right? Terraform up. Now, what this is going to do is it's going to compile the code, and then it's going to run and then basically tell me what it's going to do. So it says that I'm going to create a stack. So a stack is the Plumi's terminology for what we would probably refer to as environments. So dev, prod, QA. So a stack is essentially the same resources or the same superset of resources, but maybe with different configuration values. So I went ahead and said yes to that. Now Plumi is going ahead and creating that. So what it's doing is it's essentially taking that C# code, it's creating a resource graph for that code, and then basically interacting with the Azure Resource Manager, the Azure API to provision those resources. So this this thing you just saw was real time. So that took 33 seconds. And I didn't show you in the code, but I asked it to give me back the connection string of the storage account, and that's what it's done. So this is something that you can then potentially pass on to other elements of your build pipeline, for example, if you needed to. You'll also see there's a URL down here, which we'll come back to in a second. So that's gone and created my storage account, my resource group. That's great. What if I now want to make changes? I don't often just create resources once and then never touch them again. So if I come back to the code, we're now going to make a change. We're going to add tags. So tags are quite a common thing in Azure. They're just essentially key value pairs that you add. But you notice I'm getting IntelliSense, I'm getting things are popping up, I'm getting validation. So I'm creating this key value pair of a tag. Now, once I have this, how do I make that change? Well, if I come back to the CLI and I run Plumi up again, then what Plumi is going to do now is Plumi does something similar to Terraform in that it maintains a state of your resources. So it's now going to compare the code I've got to the state it thinks that the resources are in, and it will do a diff. So now you can see that it's saying I'm going to change these tags, and it lets me drill in further, and I can drill in and I can see that this tilde means it's going to modify, and it's going to modify these tags, and it's going to, the plus tells me it's going to add those key value pairs. So if I let that run through, hopefully that UI gets out of the way. We'll see again, this will take, just a few seconds to go ahead and update those resources. So that 11 seconds later, we now have those tags applied to my resources.
Those are the same as the what ifs that we have like on command line when we're doing like the Azure CLI, because it's similar to that.
Yeah, so ARM has a what if, but in my experience, it works 2% of the time, if that. That's maybe generous. Most of the time, it doesn't give you a good what if. It doesn't tell you the state it's going to change. So this is much more aligned to the way folks who may be familiar with Terraform would see as well. That it's maintaining this state. Cloud provider APIs can be quite tricky. So the CLI approach can be quite tricky sometimes to do what ifs on, especially on a complex deployment. So I mentioned this URL. So let's dive in. And what's this kind of a URL here? Sorry. Let's have a quick look at the resources that it created, because there's a couple of interesting things here. So in my portal, what I can see is I have this resource group. And the thing you'll notice is these strange numbers on the end. And that was never, there was nowhere in the code where it was going to do that. It was just called resource group. So where these strings come from. Same with the storage account. There's these random strings at the end. So one of the things Pulumi does by default is it will it'll append these random strings to essentially generate unique resource names. What it's trying to do is to avoid collisions. Now, most organizations will have some kind of naming structure, and generally speaking, having these random strings maybe doesn't sit super well with those orgs. You can override this behavior. It's very simple to override this behavior and not do that. But their recommendation generally is to let it do the random strings. You can still follow some kind of naming structure as the first part of your resource name. But of course, there are some limitations. Storage accounts are a really good example where most naming structures fall apart when you do storage accounts because they have very limited number of characters and you're only allowed certain characters. So, but yeah, you can override that behavior. Once I'm finished with those, so you saw it showed my connection string on the screen, and obviously this is being live streamed at the moment. So am I worried that somebody's gone and taken my storage account and started using it for nefarious purposes? Well, one, this is a recording from quite a while ago, so no. The other nice thing is very easy to clean up after yourself. So you can just go ahead and say Pulumi destroy. It will tell you what it's going to do, and then you can just hit yes, and generally you can just walk away and let that do its thing. So I do this a lot for a lot of demos now. This is the way I would do it. And in fact, anything now, I think if I'm creating an example infrastructure for sharing, I will first do Pulumi, and then I may do other examples. This particular recording, I did have to clip a little bit because it did take slightly longer. So you can see that it took 55 seconds. One thing to mention here is people sometimes ask me, is it faster than using ARM templates or slower? And the reality is all cloud APIs are, they're essentially asynchronous and they're not necessarily deterministic. So what takes 10 seconds today may take 25 seconds, 2 minutes later. It's just quite variable. So there is no real performance benefit over one or the other, because invariably the key driver for the behavior is really the underlying implementation of the API and what's happening on the cloud provider side. There may be some silent failovers and whatnot going on. Finally, we can talk about the Pulumi console. So each of those Pulumi up and Pulumi destroy gave me a URL. That URL pointed to the Pulumi console. So this is the only bit of the Pulumi platform, if you like, that is not free and open source. But you can use Pulumi entirely without using this console and without paying Pulumi a single cent. But this does add some really nice things to it. So you can see here I've got my project. So this is my project up here. In fact, I'll let this kind of recording roll a little bit because it will kind of point out the same things, and we'll dive into this a little bit later as well. So the key thing here is I can see all of the state transitions my infrastructure went through. So here's that update one. I can see when I provisioned some resources. I can see all of those details that I provisioned it. And then I can see that I did the update. So this one should be the tags. I can see the tags change I made. And then finally, I can see that I destroyed it. So I've got the single pane of glass, if you like, where I can go and look about my infrastructure, what state it's in. And that's really, really quite beneficial. And, especially if you're doing this as an org or a smallish team, then that becomes really powerful because now you've got good control over it. You remove the rights to modify your infrastructure from the standard developer accounts and then let Pulumi do its thing. That way, you know that the infrastructure is being controlled by Pulumi only, and that can be really powerful. Cool. So where does Pulumi really kind of come into its own, if you like? If you're a team that is very familiar with one of those general purpose programming languages, so .NET in my example, I guess, then the number of people who can deal with or do stuff to your infrastructure is widened a little bit. We're not living in that world anymore where there's a dev team and an ops team and and we chuck things over the wall, right? That's all gone. We've been doing DevOps for years now. So developers should be responsible and be empowered and equipped to manage their own infrastructure that they're creating for their resources. So having a language that they're familiar with will really help. And in particular, the language constructs that you have, as I said, the loops, the conditionals are very familiar to us. Those are all, I do a for each in .NET if I want to do a loop and create lots of websites. I don't need to do that horrible copy index function. As we'll have a look at in the demos, you're starting to use tools that you're familiar with. So I was using VS Code there. You can use, whatever, Rider or Visual Studio, whatever you want to use. We use GitHub to store this code. We follow, pull request process. We do all of these things that are I guess, almost bread and butter now for most developers around the world. Hopefully there aren't many people still creating zip files and saving them on shared drives, things like that. And then having that console, so admittedly it's the paid for feature, but having that console means that everyone can get a shared view of where your infrastructure is at, and also see who's changed and what's been changed. I didn't show it there. I'll show it when I dive into the demos, but it also shows you links to your Git repo as well, so you can see the actual hashes of the Git code that was responsible for that change. One other area where using this general purpose programming language is if you want to invoke third-party APIs who don't have a provider, then you're writing C# code in this example, or we're writing .NET code. So as long as they've got an SDK, if I go and grab their SDK, I can write code to do that thing the third party needs me to do. And I can even take variables from Pulumi and pass them to that third party. That integration is much, has a lot lower friction, and it's essentially more seamless, right? It's what you would expect to do in that situation. Take a variable take the connection string access key and create another resource. Give you an example which I used to have in this code, which I've taken out now, but you used to. There's a feature called Azure websites using storage. I can't remember the proper name for it, but there was a setting that you would enable in a storage account, and essentially it allowed you to serve up some static content as a HTML page. When that feature was first released, it wasn't available to enable in the ARM templates. So you couldn't do it in an ARM template. You couldn't do it in Terraform. The only way you could do it was through a management API, the Azure SDK for storage, or in the portal. So I was starting to use Pulumi at the time, and I basically NuGet package added the Azure Storage SDK, grabbed the connection details from the Pulumi code, passed it to the SDK, and told it to enable that flag, and it just worked seamlessly like that. There's no dropping down into PowerShell or Bash and anything else. So it's just really seamless. I mentioned the developer workflow. So one of the nice things with Pulumi is they've got a GitHub app that will allow you to do a more traditional kind of GitHub flow where you'll create a pull request for a change, and then Pulumi will do the preview and it will show you what the changes. I realized actually when I've been showing all those snippets, I went straight to Pulumi up. There is a concept of Pulumi preview, so a bit like Terraform plan, where it'll show you what it thinks is the current state versus what the new state is, but it doesn't do anything else. I generally do Pulumi up when I'm doing non-production stuff, because it does essentially a plan anyway, a preview, first, and then it gives you the option to go ahead and do the up. So you can see here what we see in our pull request is somebody will make a change in infrastructure, and we will get in the pull request, we'll get what Pulumi thinks is the state change. And me as a PR reviewer now has a lot more confidence that the change that somebody's made is going to do the right thing. It's going to, this is what it's going to change in my infrastructure. This is, hopefully you're sitting there saying, this is great. What do I do about my existing resources? I already use Azure or AWS, and I've got a bunch of existing resources. What do I do with them? And this is the state we're in at the moment at Aura. So we've got extensive Azure Resource Manager templates, and we're now using Pulumi as well, and we're in this kind of situation. So Pulumi is quite flexible in how you deal with existing resources. So what you can do, and this is kind of roughly where we are at the moment, you can have them coexist. So we have the stuff that we've deployed through ARM, and then we have some of the new stuff that's now being deployed through Pulumi and managed through Pulumi. And they coexist. They don't really touch each other. The one big gotcha here is do not create your resource group with Pulumi if you are going to use other tools to add resources into that resource group, because one thing Pulumi will do is it will delete all the resources that it manages, but when it comes to the resource group, it's a resource that it manages, so it will delete the resource group. And generally, by default, if you delete a resource group, everything within it gets deleted, whether Pulumi knows about it or not. So that's a bit of a gotcha you just need to be mindful of. But you do have that option. Another option is what you can do is you can write the code for it. So let's say you've got a web app in production at the moment. You can write the .NET code for that in your code. Say here's a web app and all of the settings as they are based on your current production version. And then you can add an attribute into the Pulumi code, which essentially tells Pulumi to adopt the existing resource. So when you run Pulumi up, it's not going to go and create another web app. It's going to see the one that you've said, this is the one that's already existing, and it will essentially adopt it, if you like. It will start controlling that going forwards, essentially. And then the third option really is to go, right, let's just start from scratch. Let's just write everything in Pulumi. Pulumi has a couple of tools to help you with that. If you've got reasonably simple things, there's a Pulumi import command from the CLI, and you give it the unique ID of the resource, and it will actually generate the code for you, the Pulumi code for you based on the language you've chosen. There's also a couple of pages on their website that give you live conversions, if you like. You can paste in an ARM template and it will spit out the code. If I get a chance in the demo, I'll maybe show you that. I found it generally it works okay to get started on really simple things, but if you've got reasonably complex infrastructure, then it has limited use because generally speaking, the only thing you can really do is look at the final result of all the ARM template modifications. So if you've done loops and stuff, it's not really going to recognize that very easily. But when it's reading the state of your resource, it's just going to read the values as they are. It doesn't know that value came from this other value and its concatenation of this storage account's name plus this thing. So it's not super smart, but it's still a really really handy starting point. Yes, sorry, I just mentioned that the Pulumi CLI, and yeah, there is also just I should really remember my slides here. So yeah, there's the ARM to Pulumi lets you convert. They've got, it's not just ARM. I think they do lots of different languages on there as well. One really nice thing, which I don't go into in detail in this talk, is everything you saw me do at the moment was running that Pulumi CLI. But Pulumi has an automation API, which means that you can do everything that we were doing from that CLI command from our own code. And that's where it gets, potentially really, really exciting, really interesting. But I think also you have to be probably a little bit careful that you're not like a kid in a candy store, right? You're not trying to do all the things. But you can basically create your own Azure portal, if you like. Please don't do that. Where you can have sets of resources that are kind of defined to your company's specification, and that people can then deploy themselves. There's a lot of value in those kinds of concepts. Like if we deploy, say, a SQL server, we would always want transparent data encryption on, Defender on, we want geo-replication on, all of these other key things we always want on, auditing, etc., long-term backups. Those all are individual resources, so we would want to package them up into another resource, and you can do that in Pulumi. And again, we won't touch on that really. This is more of a level 100 talk, if you like, but you can do that. And then the other thing I realize I don't cover in this talk much is testing. So because we're writing .NET code, we can write XUnit. You can write MS test, God forbid, but you can write a XUnit test that tests some of the logic you might have in your C# code. For those XUnit, those unit tests, you are just testing the actual code, so it doesn't need the Pulumi CLI or anything else. But you can also do property testing and integration testing, where your test may actually spin up the infrastructure, validate something on that, and then tear it down at the end. So all of that's really possible as well. Again, it's really quite awesome. So what are the kind of pros, really? I'll put my hands up. I think this is a fantastic tool. I came across this somewhere around 2.5 years ago, I think it was probably 2018, 2019 maybe, I can't remember now. It really just changed my outlook completely on these things. You're using languages that your team's already familiar with. If you're a software house, you're going to have far more people who are familiar with .NET or TypeScript, then those are going to be familiar with ARM's weird syntax. As I said, you use the power of modern programming languages. I think it's actually really easy to get started as well. You can get started from zero to thing in about 5 minutes. And as I said, it's free to use and it's open source. It's just that console, that console I showed you, that adds all the nice features. It does do things like secrets management for you as well, which we can touch on when we dive into a demo. And then yeah, this Pulumi automation API is quite exciting, but I would urge caution. Please don't reinvent the wheel completely. I think it has a lot of power, but comes with responsibilities. So you're probably wondering about pricing. I said it was free, right? So yeah, that's great. And then you as an individual, so you want to try this out. Everything I've done so far has been on my personal individual account, and that's basically one login. You can pretty much do everything on that. Unlimited deployments, unlimited projects, whatever you go crazy really. Then we kind of move into kind of proper pricing. They changed their pricing. Probably been more than a year now, but time is a weird concept since the pandemic. But essentially, what you have now is in the team tier, you have this concept of credits. So you essentially pay for the resources that are managed by Pulumi. I'm still on the fence about how I feel about this pricing model. The previous pricing model was seat based, but it had a very big increment between. I think it went from 5. The jump from 5 users to 5+ was quite a significant jump. So yeah, I don't think they're going to change this, but it is what it is. And as I said, if you want to have full control, or you're in some kind of environment where you can't allow anything to be outside of your environment, you can run Pulumi yourself. So you can store the state on your own backing store, whether that's local computer or cloud storage of some kind. And you can also integrate with your own secrets provider. So we'll touch on the secrets, I think, when we get into the demo. So what are the issues with Pulumi? It has fewer supported platforms than Terraform. You saw in that screenshot there was about 96, let's say give or take 100. I don't know what the number for Terraform is, but I know it's significantly more. Reality here is, does it matter? I mean, I guess it only really matters if your specific use case isn't catered for, right? If I don't care if there's 2,000 other providers, if I'm never going to use them, it's irrelevant to me. But yeah, just worth pointing out. And I think a big one now, say if you are somebody who is more on the kind of cloud architecture or the DevOps side of things, this isn't gonna make you redundant. Giving your developers the power to do this isn't going to make your job redundant, because somebody still needs to understand all of that cloud provider API. Do I use a local redundant storage versus a zone redundant or a geo redundant? What about a read access geo redundant? All of those things are still things that somebody needs the knowledge about. So unfortunately, that's unavoidable. That's unavoidable no matter what you do. This is the nature of dealing with the cloud. You have to learn something to help you manage it. Dare I say, people might say things like serverless and Kubernetes solve that problem for you, but I don't agree, and we don't have time to go into that. But love to have a debate about that at some point, or a chat. Some errors you may encounter when you do a Pulumi preview will give you a reasonably good idea. So one of the things Pulumi preview will do is make sure your code compiles. So that's the first step. So that's all good. It will do some additional validation, but there are some errors that are not apparent until Pulumi Up starts trying to provision those resources. In most cases, this is because the cloud provider's API hasn't surfaced the possibility of those errors or any validation around them. So when Pulumi goes and starts telling the cloud provider to provision something, and suddenly the cloud provider says, well, hold on, you didn't give me this property, but it never said that was mandatory. I'm guessing they're using things like OpenAPI behind the scenes to generate this code. But yeah, you can get Pulumi in a bit of a weird state. So especially if you cancel while it's in the middle of provisioning stuff. So I mentioned that the way it works, broadly speaking, is that your code that you've typed in your general purpose language gets translated into a resource graph, and then Pulumi essentially makes CRUD requests to the cloud API to provision those resources. Now, of course, all of those cloud provisioning steps are asynchronous. You tell the cloud to go and create you a database, and it will eventually tell you it's done. So if you hit Control C and break Pulumi out of its running step, then it's going, well, I have no idea what's happened now. I told Azure to start creating a database, but I didn't get a chance to tell it not to. So you can get stuff in a state. It's actually reasonably easy to recover this. And if you do work with Pulumi, I'd recommend testing that. Like, it's a good scenario to validate that you can test it. It also really reinforces your understanding of how Pulumi works as well, I think. But yeah, I've had less of those problems latterly than I used to originally way back when I first started using Pulumi. Okay, so now we kind of come on to some comparisons. So most cloud providers have their own SDK. Why don't we just use the SDK? Those SDKs are generally just abstractions over the REST code. So you as a code author is essentially kind of making those REST calls. They're generally imperative, so you are going to have to do all of the calls in order to provision the state as you want to see it. Not all of those REST calls may be idempotent, so you may make the same request twice, and you may get two instances of a resource when you didn't intend that to be the case. And then the big difference really is it's very hard to reason about the current state of your infrastructure versus the new proposed state when you're using the SDKs. There's also a group of tools called transpilers, I guess you'd call them. So AWS has their CDK. Again, this information may be slightly out of date, but I know originally the CDK used to spit out CloudFormation templates. I believe it still does, but I'm happy to be corrected on that. So AWS CDK, basically you write your code in general purpose language, and then it spits out CloudFormation templates. Pharma is a open source project that lets you write F# code to generate ARM templates. F# is a really nice language for doing some of these things. You can get some really, really terse syntax. They've been around a long time. I think they predate Pulumi as well. And then Terraform now has a CDK which does a bit similar to AWS. It spits out essentially Terraform files from general purpose programming languages. And I think again, I don't work for Pulumi. I have no shares in Pulumi. Pulumi have sent me a T-shirt and a Rubik's Cube. I will confess that much, in terms of my association with them, shall we say. The fact that these other providers are doing similar things, you can argue about the timings. I know Pharma was probably around before Pulumi. AWS probably started doing CDK before Pulumi, but certainly Terraform. For me, it feels like a validation of this is the way we should be doing things, and that's what all these other providers are now trying to support it as well. I mentioned Bicep. I said I was going to touch on Bicep. So Bicep is Microsoft's kind of new DSL, domain-specific language for creating essentially ARM templates. So it's a vast improvement over ARM templates in terms of how verbose it is, and it essentially looks very, very similar to Terraform. It's a lot cleaner syntax, but it has a lot of the similar limitations that ARM has. In the main one being that it's only for Azure. So if I want to provision other resources, I'm back to whatever I was needing to do before. So I think Bicep is great if you've got a bunch of ARM stuff and you don't think Pulumi is for you. Then Bicep feels like a bit of a no-brainer for you. Like I don't know why you wouldn't do that. Move to Bicep. Where's my demo? Sorry, I think I had a demo slide somewhere which is missing. So I'm just gonna cut across to some demos because I don't want to. The demos they're showing you are a bit kind of basic, and I'd like to do something a bit more interactive. Conscious of time though, so I will whiz through stuff a little bit. So what I wanted to show you was that screenshot I showed you before was a really simple storage account. So let's have a look at something that's slightly more complicated, just to kind of really get a feel for this. So this now is I think I upgraded this manually, but this is now Net6, targeting Net6, still a console app, and it's using this Azure native provider, and random I'll come on to in a second. So all of my code is really in this stack here, which inherits from this base class. The rest of the syntax is similar to what you've seen already, and as I said, we get, you get IntelliSense here. I can pick the different types of storage account I want. Just going to leave that one as LRS, but you can see got compile error, so I can't do anything with this code until I fix the compile error. So that's great. That's something I'm familiar with. Amount of times I've run ARM templates only to get an error and then fix an error and run it, another error, is just like incredible. So here what we're doing is we've got a resource group. We're creating a storage account. We're creating an app service plan. So this is essentially web servers for running our web apps. In our storage account, we're creating a container. And what we're going to do is we're going to upload a static file into the container. So this is a bit of a demo where, like, I don't necessarily recommend you do this in your real code, but we're essentially creating a resource group and we're going to upload a zip file to that in a second. And just to kind of show you how other components fit into this, they're not used in this demo per se, but we're creating an App Insights resource. So this App Insights is where we can see the logs and telemetry from our applications. And then I'm creating a SQL Server because why not? One of the things with SQL Server is you need to create an admin password, a random admin password. And in this example, I don't care what the password is. I just want it to be random. So they've got this useful library called random, which lets you generate random things. So I'm just generating a random password that I'm setting as the password here. I'm creating a database in that server. So you can see here that my SQL Server name is server.name. And then I'm creating a web app. And I just kind of wanted to show you that how we use the value. So here's the app settings in Azure Web Apps. And what we're doing is we're setting some app setting values based on those other resources. So here's the App Insights connection string. You might be looking at this syntax, and this syntax looks a little bit weird. Like, what's this apply and this lambda expression doing? Well, one of the things I touched on a couple of times is Pulumi is declarative, not imperative. So when I run this code, a bunch of stuff is happening that's asynchronous. So the Pulumi API relies on these things called input and output. You can see there says input of string. These are essentially promises, is probably the closest thing to think about, the equivalent. Excuse me 1 second. Let's grab my water bottle. They're essentially promises, and what the promises are doing is, well, when that value becomes available, then I will put that value in this place. So what we're doing here is we're basically giving a function that is going to run when the value for the instrumentation key is available, and then it will format it in the string like this. And then similarly with the connection string, this one looks a little bit more complicated, but it's doing the same thing really. It's taking the name of the SQL Server, the name of the database, excuse me, and the password, and it's generating a connection string for that. And then it's spitting out the URL. Excuse me. I definitely don't talk so much this time of the evening. So once I've got this, what can I do? So I can go ahead and now provision this. I'm going to do this all in VS Code in the terminal just to make life easier. And I've aliased Pulumi to P in this environment because I'm lazy basically. So what I can do is if I do now Pulumi up, that's going to go and show me what it's going to do. So it's essentially going to do the preview first. Hopefully I haven't broken anything. That looks all good. Looks like it compiles. So the first step is always really compilation, and you get restore if you haven't restored the packages already. And then obviously, because this is a live demo, things always feel like they take a lot longer. But yeah, you can see now there is a bunch of stuff that's going to create. There's 11 resources. I can click on details and go into it, but I won't for now, just in interest of time. I'll just hit yes on that, and we'll let that go and create that. That will take probably about 90 seconds, I think, maybe slightly longer. It does vary. While that's running, let's have a look at the Pulumi console. So I said I was going to dive a little bit more into this. So here's this demo project. You can see I've had a lot of updates to it now since I've been using this a fair bit. And here, for example, you can see the Git hash for where this was, connected from the code that was used to run this. Probably just rerun that, refresh that, so you can see the latest preview. While that's also running, I'm going to just jump back to the code a second because I wanted to touch on the secrets as well. So one nice thing is that in my file here, you can see I'm using a service principal. I've got a client ID and I've got a client secret, but this client secret is encrypted for this specific stack. So this value is no longer available to me. I can safely commit this to my source control. And even if somebody copied this value, this config, tried to put it in their own code, it wouldn't work. It's encrypted per stack, so per environment. Now, of course, some people still wouldn't want Pulumi to manage their secrets for them. So for us in production, we use Key Vault for our secret. And in that situation, what Pulumi actually does is it encrypts the values in the file using a secret from your Key Vault secret. But then you can still save the rest of the stuff into the console and into source control. And that's all kind of fine to do as well. And as I said, you don't need to use any of the Pulumi console. You can just run it completely yourself and manage the state yourself as well if you wanted to. So that's that's just running now. What I'll do is I'll dive across to GitHub for a second, and we can start doing another kind of demo really, and then we can come back to that one. So I mentioned about developer flow, right? And you saw a screenshot of it. So let's have a quick look at that. So if I go to this this branch here, can I reopen that pull request? It's probably doing. Tell you what, in the interest of time, I won't redo the whole demo. But here you can see that I made a change. So I'll show you that change quickly. So I added a new storage account in my code. And in my pull request, what I can see now is Pulumi basically showed me the differences he was gonna do. So now as a pull request reviewer, I have some idea of what Pulumi is going to do. And that's really helpful. So let's go back to VS Code quickly. And yeah, we can see that's finished. And it's given me the URL. So I didn't give it a friendly name. So it's given me this random string. So if I click on that, what we should see, hopefully, is in a few seconds, we should get an Azure Websites address up, and it should be my static content from my HTML page. And there we are. So yeah, and that's all done from Pulumi. So as I said, a bunch of resources we didn't really need there. I'm going to quickly delete the stack a second. No, actually, I won't. I'll show you another demo quickly. So one of the reasons you might want, you don't like this is because, well, I need those values, right? I need to know what my website name is because that's no use to anybody. Well, I mentioned how that one of the beauties of Pulumi is you can interact with other services. One of those services is Cloudflare. So in this branch, I've included a provider for Cloudflare. Let's just jump across here. So now I've got Pulumi's provider for Cloudflare. And then in my code, what I'm doing is I'm binding a custom domain to the Azure Web App. So this is a two-step process in Azure and most places. You generally have to verify you own the domain, and then you have to bind the domain. So this is a demo that will fail maybe 50% of the time because it's DNS, so obviously. But what I can do is let's do a Pulumi up on this. Really conscious we're running kind of quite over on time. So in this example, I've deleted a bunch of the other resources I didn't need. So what you'll see is some deletions in here. So I'll be deleting some of the resources because it doesn't really need them. The key difference here is what we want to see is now, do we have a custom domain from Cloudflare, custom subdomain, I guess more accurately, bound to this Azure Web App so that when we run it, we get a friendly DNS name and not a thing. And as it's running, I can show you here how we can interact with. So here's me creating a DNS record in Cloudflare, and here's how I get the value for the host name. I'm just dotting into the app. I can press Control click and jump up to the web app where that variable was. It's all. It just makes so much sense when you start working with it. So we can see here that it's going to delete. I'm just going to say yes to this quickly. We can see now that it's going to delete 3 resources. It's going to update one, so it's going to update the web app because it's going to add the binding to that, and then it's going to add these Cloudflare records. And hopefully this doesn't take too long. But what I'll do actually is let me flip back to the slides, and then I'll come back to this, and we can just finish off with hopefully either a failed demo or a working demo. So one way or the other, we're all happy. Let's jump back to here. So really the way I think about this when I put it into context is that when you first start on this journey, your evolution of the, of your cloud infrastructure, you start with the portals, and that's arguably quite primitive. They still have a lot of value, by the way, don't get me wrong, but it is a starting point. And then you mature a little bit, you evolve a little bit, and you start using those templating languages, and they're great. I personally think Terraform is a step up from those cloud languages, and I guess Bicep is testament to that. But really, Pulumi changes that. You're now evolved into a fully upright, Homo sapien. So if you want to learn more, Pulumi has tons and tons of examples on their GitHub repo. They have different languages, different platforms. Their Slack, which I've not, to be fair, I've not been on for a long time, but it's really active, and the Pulumi folks are just super supportive. They will jump in and help. I mean, I ask them questions on Twitter or DM them, and they will generally give me help within minutes, often on Slack. They're so good. I've got my blog on there, but I haven't really blogged for such a long time, so ignore that one. I will get back to doing that stuff, but yeah, I moved from the UK about 18 months ago, so, and then new job and everything else. I think everyone's got excuses why they don't blog, and that's a good one for me. Finally, on this point, I'll say thank you just from the slides point of view. I work at Aura. We're in New Zealand. We are hiring. Please go and check out our careers page. If you're in the UK or abroad and you want to come to New Zealand, we are now an accredited employer. So if there's a role that fits you, you could potentially, we might be able to get you to come to New Zealand. Our core engineering team is in New Zealand. So we're remote friendly, very remote friendly, but New Zealand time zone, basically. So let me jump back to my demo. And hopefully we have finished. That took 1 minute, and apparently it didn't fail. So now if I go to this URL, oops, go back to the browser here. And there we are. So now I've got a custom domain, got TLS, and I've deployed my app. So that's it. That's it from me. Come back to the slides just to leave out my contact details. Yeah, I didn't see any questions come through on the chat. But
No.
if
Yeah, I think like I got like a couple questions like
yeah,
but it's more about like what your experience, right? And I liked on PRs, for example. I like that app that we can integrate on GitHub. Is that like part of like the free tier, or do you need to have like some sort of license for that?
no, that particular GitHub app is free, I believe. Yeah, because yeah, I've used it on the. I mean, I'm on the free tier on that demo example. So yeah, I believe that's a free one. I think there is some additional capabilities you get as part of the team tier. I think there are some CI/CD integration helpers, but
Yeah.
I don't know specifically what they are versus what we had there.
Yeah, I really like those stamps, like from PRs, and you get like those insights. I think those are really powerful, like for when we work like on teams. And the other thing is about like the unit testing. Yeah. Well, it's interesting, like you mentioned about testing, because in general, like for example, let's say if I would say you're gonna have business rules, but maybe you expect for some provisioning to have maybe provisioning like three storage, right, storage accounts for that, and then you could put like some validation. I don't know if I explored, but like, is there a way like to mock or just to not provision, but to validate some logic in there?
So yeah, I think that's probably what comes under what they call the property testing. So generally speaking, you will do unit testing is where you might have some logic. So you may have this loop. So let's say, to take your example, we might be creating a storage account that's should be called company name dash storage account one, and you got three different companies, and you want to validate that it does that it creates the correct name for that storage account based on the company name. And storage accounts probably a really good example because storage accounts have a real limitation on the size and the characters. So you could have a customer who's got a character which is not allowed in a storage account name. So you could
Correct.
write a unit test that would do that looping and create the storage account. You could validate that. But that, I think the specific example you mentioned is probably what they refer to as property testing. I
Hmm.
There's a bunch of stuff that I didn't want to dive too deep into because this is a kind of intro level talk. But
Correct.
I think I'd love to do a more detailed talk and dive into those things, or possibly even a workshop of some kind. I think as people use this, they will. I don't know anyone who's started using this or seen this who doesn't love it.
Hmm.
Um, you know, we we started integrating this into our continuous deployment pipeline. So our Aura we deploy multiple times a day,
Hmm.
and we've deployed some of our Pulumi infrastructure currently is in that deployment pipeline. Now, as it turns out for us, in our use case where we use a lot of PaaS services, it's
Yeah.
probably not ideal for us to have the whole infrastructure in that pipeline because some changes will take a very long time to run. So in some Azure services, so like API Manager, for example, some changes can take 30 minutes to run.
Yeah.
We don't want our deployment pipeline blocked for that. But in other cases where we are doing, where let's say we're updating an open API spec or we're updating app config settings, then those
Hmm.
could be in the pipeline. So we're still reasonably early on our journey of pluming all the things.
Hmm.
So I think we're going to revisit that and see how we can make that work. But
Yeah.
ultimately, yeah, the goal really is that I want my engineering teams to manage the resources they need for their features, and we help them with it rather than me manage them for them. So, you know,
Yeah.
that's kind of where we're getting to. And in our team, everyone, there's not a single person I've spoken to about doing that where they've gone, well, I don't want to manage any of that. Most developers want to have control over their resources. Like,
Mm.
what's the reverse? Send a fax to somebody to provision your cloud resources for you. We're back to the data center days, right?
Yeah. I just got like a, well, I don't know if you can share like this project link or like GitHub. I'm not sure if you have that available. Yeah, just
Funny
like
enough,
getting this question from, yeah, it's just like a request from Shafiq Mohammed.
yeah, Shafiq, I don't know. I think it might be weirdly, it might be private. There's probably no reason for it to be private. But I can share. What I'd recommend is having a look at the Pulumi documentation. They have the examples there that you can follow. My example there is nothing special, to be honest with you. It's not doing anything um, new. So what I would recommend doing is, for example, I would say just go and once you install the CLI tool, you can just do the Pulumi new. I won't run it all here. But if you do Pulumi new, it will give you like a little interactive. Oh yeah, it would help if I was in a um, blank folder. Do that.
Hmm.
It gives me this template, so you can see that I actually have lots of different. lots of different templates to start with. That will give me a starting point, and then really the individual code here. There's nothing. I'm not doing anything magical here, to be quite honest with you. But should we hit me up on LinkedIn or something if you specifically want this? I can probably make it public. I don't see any real reason not to. I think it was just because I've been experimenting with it a lot. So I might repos generally private starting point. So yeah,
That's cool. And
cool.
like while you were talking, I put like a poll, and if I can allow me just to share,
Yeah,
then like
sure.
so let me bring share my screen. So it should be this one in here. Share. All right. So let me just zoom in. Oh, not this one. Should be this one. Right. So we had like in here, I didn't close the poll, but you can see that people are studying, right? I think like from developers in general, we don't tend to do it that often. We just rely like more like on, I would say the infra engineers, but now we're working together doing that. So people are studying, which is great. And that's a like really good session for any developers jumping to infra as codes, right? More like infra as software in exploring like the Pulumi. Seems like really great tooling.
Thanks for doing that poll. That's really interesting. Yeah, so hopefully at least 85% of the audience it was relevant because they're kind of studying it, and I would, maybe the other 14% I can convert. And as I said, I don't work for Pulumi, but I see very I can't see myself going back to using anything else. Like, why would I go backwards? Why would I
Yeah.
devolve? Like, for me, it's such a big change. And I follow some of the Twitter threads, and I heard somebody from from the kind of DevOps opsy side say, "Well, I don't want to be an engineer," and I'm like, "You don't have to be an engineer just
Yeah.
because you follow good practices." Like maybe 10 years ago, infra people didn't use GitHub, and now they hopefully all use GitHub, right? These are things that are just good practices. You don't have to. We're not saying that you should change, you become an engineer. Like being a software developer is a very different kettle of fish to doing
Mhm.
using Plumi to do what we've been doing. Our skill set, admittedly, I span the software. I mean, I spent 12 years or something doing more traditional classic software development, and then last 7 or 8 doing um, infrastructure. And for
Mhm.
me, they are marriage made in heaven.
Correct.
But if you're coming from a more ops background, then honestly this tool is just going to equip you with the stuff you need versus having to. I mean, yes, you can do it in PowerShell. Yes, you can do it in Bash. You can do it in pretty much any other language, but um, it's going to be a general purpose programming language will give you the most power to do what
Mhm.
you need to do. Um,
Yeah.
yeah,
No. Thanks for sharing with the group. Yeah, I'm definitely keen like to explore and go like a little bit deeper on that. I'm very familiar with ARM and Bicep, but Pulumi like is something new, and yeah, just really keen to give a go and explore. The the
awesome.
the, the conversation was really interesting. We just stretched a little bit more, but yeah, just I was really keen like to see like more like the demos. Yeah, thanks
Yeah,
for
if
that, Shahids. Yep.
yeah, awesome. Thank you so much. I appreciate you getting up so early or staying up to host me as well. And thank you to everyone who joined online and watched. And yeah, please fire any questions. If you're working with Plumi, I'd love to compare notes and see what problems you're having versus what problems we might be having, because I'm sure we could learn from each other as well. So yeah, thank you so
Cool.
much.
Yeah, with that, like we're ending the session. This is going to be recorded, and then if you can just revisit and check like the demos of this session anytime. So thanks, guys. Just